Welcome to the Congruence podcast. Right, so we're going to go over these two problems and decide whether we can use hypotenuse leg triangle congruence theorem to show the triangles are congruent. Right, we did the first one in class. I wrote it just a little differently, but the same information. So it's given that triangle ABC and triangle FED are right triangles. We can see there's a right angle marked in both. And since AC is congruent to FD, we're given that. And AB is congruent to FE. Oops, it's just get the bottom of the line. There we go. Which are the hypotenuse and leg of the triangle, right? AC and FD are the hypotenuse of each of the two triangles, and AB and FE are the legs. Then triangle ABC is congruent to triangle FED using hypotenuse leg. And I probably should write triangle congruence theorem. Just squeeze that in there. Let's look at the next one. All right, so again, we can see the markings as a right triangle. So it is given that triangle JKL and triangle JML are right triangles. And legs JK is congruent to JM, right? So we're given that information. We're given it's a right triangle and that the legs JK and JM are congruent to one another, right? Remember, we can mark that using the reflexive property. So using the reflexive property, JL is congruent to JL, and that happens to be the hypotenuse of each triangle. The hypotenuse of each triangle. Wish I could write a little faster. All right, so therefore, I'm just going to use the symbol, the mathematical symbol for therefore. Therefore, triangle JKL is congruent to triangle JML. Oops, I figured that was going to happen because I hit the extend to page. Let me see if I can move it down, because I only needed really just a teeny weeny bit of page. There we go. Using, now I'm way at the bottom here, hypotenuse leg triangle congruence. I think I'm just going to leave it hypotenuse leg. I'm kind of running out of space there. I can just move it up a little bit. There we go. Hypotenuse leg. I'll just use HL triangle congruence. Good enough. We got that in there. All right. So again, I can use hypotenuse leg. This, of course, is the hypotenuse because it's opposite the right angle. Same thing here. All right. So I thought it would be a good opportunity to practice some paragraph proofs. That's why I did these as paragraph proofs. Let's look at the last one. All right. Well, it's given, it's a right triangle, right? It is given that triangle P, well, okay, let's start with the Q. QPT and triangle SRT are right triangles. However, it is not known that PQ is congruent to SR. We don't know that the hypotenuse and the triangles are congruent. And so therefore, hypotenuse leg could not be used to prove the triangle is congruent. So we can't use hypotenuse leg. So it's a no on hypotenuse leg. I'm just going to use this symbol for congruent. But we could use the theorem to prove the triangle is congruent, right? Because we have side, angle, side. But so side, angle, side, triangle congruence postulate could be used. Right? just squeeze that in there. So we could use side angle side, but we could not use hypotenuse leg. All right? So there are those problems and just a little review of hypotenuse leg. For the next part, you're going to need that one-page note form I gave you. And you're going to take some notes. And we're going to get a lot of information out of these notes as soon as the page changes. So this is the first half of the notes. It is posted. If you need one, go ahead and print it out. We're going to determine together whether the given information is enough to prove whether the triangles are congruent. If so, we're going to write a congruent statement and state the condition. And when I say state the condition, it means which congruence postulate. Right? We have 5. Side, angle, side, 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 angle, side, angle, 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 side, and a hypotenuse leg. Right? So that's going to be very similar to the second page of your homework. Matter of fact, it's exactly identical. We're going to do one other piece, though, just to review, and that is we're going to state the type of transformation that maps one figure to the congruent figure. Okay? All right, so let's start off with this one. Well, we could mark AC congruent to AC, or CA, couldn't we? And let's just write this over here. This is the reflexive property, just to remind ourselves. All right, so now we do have enough. The triangles are congruent, and I'm going to name them. So triangle ABC, all right, that would be congruent to CDA. And I'm going to abbreviate the congruence postulates using, we have side, 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 triangle congruence postulate. We're just going to put side, side, side. All right, what transformation would map? All right, so A here, so I'm gonna map ABC to triangle CDA. So A here has to come over here, right, to the C. All right, so it's not going to be a reflection. It's going to be a rotation. And actually, you know what? I'm going to do this. All right? I think that will help you be able to see it. All right? So you can just kind of watch here. So I think this is the one that just rotates it. So if I rotate it 180 degrees, and I didn't rotate it exactly around the right point. I wanted to rotate it around the middle there, but I don't have that ability. But if I were to rotate it 180 degrees around that middle piece there, all right, then I would map one to the other. So you can see that. Right? So that's going to be a 180 degree rotation. So triangle ABC maps to triangle CDA by a 180 degree rotation. And I don't really have a good way to explain it, so it's just going to be about the center of ABCD. Right in the middle of that figure. If I could rotate around that point, right, then one would map to the other. I kind of rotated around itself. That's why it doesn't map exactly. All right, so let's take a look at the next one. All right, so these are congruent, right? These are vertical angles. We should probably write that. Okay. So now what do we have? We have side, angle, side. So triangle WXV is congruent to triangle ZXY using side, angle, side. All right, and what's going to map one triangle to the next? All right, so look at the way the congruence marks go. All right, and I'll just draw that. All right, so I have to rotate this. Now, I unfortunately can only rotate this right around, you can't see where I'm pointing, around the center here. What I'd really like to do is rotate it right here, but I don't have that ability. So it would rotate, but when it rotated, if it was rotating around the center point here, it wouldn't end up where I have it. It would end up over here. Right? If I was rotating around that point, I just wish I could do that. And it would end up right there. So again, that's going to be a 180 degree rotation because you see there, I'm going to move this triangle out of my way. We have a straight line. Right? It's mapping from this straight line to this straight line. Right? So that'd be 180 degrees. So triangle ABC maps to triangle, oops, I'm looking at the wrong triangles, I'm sorry. They're not ABC, they're WXV. maps to triangle ZXY by a 180-degree rotation about point X. Right? That's what's rotating around. Let's look at the next one. All right, so here, well, let's look at what we have. We have side angle. All right, so these are not congruent, and when they're not congruent, we're going to explain. You're going to do the same thing in your homework. All right, so here, the triangles are not congruent because side angle is not a triangle congruence postulate, and we need to explain why. That's really quite not enough. Why isn't it a triangle congruence postulate? Well, it's because the angle needs to be located between the congruent sides. So the congruent angle needs to be between the congruent sides. I think I wrote smaller. I did this before with fifth period. They just finished this in class. And I think I wrote a little bit smaller because I was able to squeeze that in. So if they're not congruent, one doesn't map to the other. So we're done with that one. Let's go over here. All right, so notice here that AB is parallel to CD and BC is parallel to DA. When we have parallel lines, remember our alternate interior angles are congruent. Right, so this angle is congruent to this angle, right, and that's because, oops, there we go, they're attached together, and that's because AD and BC are congruent. This C looks an awful lot like an L, doesn't it? And these two angles are congruent because AB is congruent to DC or CD. All right, so, and we know this is the reflexive property, right? AC is congruent to CA. And that's the reflexive property. Right, so here we're showing why these things are true, right? And we could easily turn this into a proof by just, listing each of these with the reason, or just by making these into sentences, we can make this a paragraph proof. So here, triangle ACD, well, I just wrote down ACD, so we'll just call it ACD, is congruent to triangle CAB, right? A and C are switched, right? And that is using, we have two angles, the side between them, angle, side, angle, triangle congruency. And this is very much, matter of fact, it's identical to the problem number 1 there. Right, so this also we would have to rotate. So triangle ACD maps to triangle CAB by a 180-degree rotation. Again, it's going to have to be the center of that figure, the center of ABCD. Right? If I rotate right in the center there and just turn it around, I'd map to the other triangle. All right, number 5 here. All right, so here we have two angles and a side. All right, well, that's got to be angle, angle, side. So triangle KL, I think it's a K, KLM is congruent to triangle, oh, I just wrote all over that. I think that's a P. Triangle P, and then L goes with O, PON. And that would be using angle, angle, side. This one's harder to see. I think the other two rotations are easy to see. This is a rotation. This is going to be a little harder to see. So let's say I don't know the number of degrees rotation because it's not like a straight line like 1, 5, and 6 were. But it is a rotation. So triangle KLM maps to triangle PON, happened to my O there and my N? By a rotation. All right. I don't know how many degrees, but let's say I rotate around L, for instance. All right, so I'm going to rotate. Now, if I rotated around L, I rotate around the center of the figure there. It would really be over here if I rotate around L. And I kind of rotated too many degrees. Let me rotate a little bit back. There we go, about that far. All right, so, oops, I want to move him, not my words. There we go. All right, so you can see there I rotated the figure, and so now all I'd have to do is translate, and it would just map right to it. Right, if I could turn it correctly. All right, so rotation about point L, and a translation. I need just a little bit more space. I'm going to do that, and it's probably going to move it too far. There we go. I told you, it'd move it too far, because now you can't see the rest of the page. And all I needed was just a teensy bit more space, a teensy bit more space. Hopefully I've given you enough space. Here, we're just going to go right to like here. And a translation, you probably can't see my words. I'm going to have to move this page up again. There we go. Good enough, right? At least you'll be able to see. And a translation up and to the right, to the right. All right, there we go. Squeezed it all in. That's good enough, right? All right, let's do the last one here. And just remember what we're doing here, our rules. All right, so we're identifying congruent or not. And then we're writing the triangle congruence postulate. Boy, I just can't get everything in, huh? I can't go, unfortunately, to full screen. All right, so this one here. All right, oops, I guess I didn't need that many lines, huh? It's the only thing that's congruent. All right, well, let's take a look. We've got, this is the reflexive property. And that's all I've got. I've got an angle and one side. Well, an angle and one side just doesn't cut it. All right, so only two congruent parts known. We need three. So three is needed, or three are needed. So three congruent parts are needed. So this just doesn't have enough congruent parts. But let's see which postulates it would be if we had, I can't squeeze are needed in here. Okay, so three congruencies are needed. Let's call it that. And now I could squeeze it in. There we go. We need three parts, not two. All right, so what if, all right, so we're just going to do a little something different here. Calling this one that's not congruent. What if angle GE, actually, what if either of the angles, so if angle GEF was congruent, so that would be this one here, right? If GEF, well, oh, excuse me, GEF, this one here. Sorry. GEF, I was thinking that one, but I said this one. So GEF were congruent to GEH. Or if angle F, what did I say? FGE was congruent to angle HGE. Okay. That would be angle, angle, side, right? The only other one we could use, we can't get side, angle, side without making two things congruent because the angle's not next to that side. Can't use side, side, side. And you can't get angle, side, angle. So that's it. But if we had one of the other angles, we could use angle, angle, side, but that's not congruent. And that's the end of this podcast. Come back for the next podcast and we're going to finish up. All right, bye for now.